if a divides m and a divides n, then a is going to divide m plus n. This is a seemingly arbitrary, just sequence of letters and symbols that sort of makes no sense the first couple times that you read it. This is a surprisingly useful tool in number theory. This and really all different areas of math. This is I can't really explain to you without showing you examples of why this is useful, but take my word for it. This is one of the most useful and fundamental facts in math, and so I want to in this video explain why this kind of works to you visually. Okay, I'm not going to formally prove anything. I'm just going to visually convince you of some stuff. So, some context. So m and n are going to be represented by 20 and 8 in this example. And what is a going to be? A is going to be 4. So 20 and 8 are both divisible by 4. 4 divides 20 and 4 divides 8. So 4 divides 20 because 20 is equal to a multiple of 4. And 4 divides 8 because 8 is also a multiple of 4. It's 4 times 2. So let's represent these two numbers. If I wanted to represent these two numbers, kind of spoiling some stuff here. If I wanted to represent these two numbers as multiples of 4, then you can do the following. Sorry, spoiling too much already. So here's 20. I have 20 things that I've represented it as 4 rows of 5, and I've represented 8 as 4 rows of 2, right? So now if I add my two numbers together, so 20 plus 8, what do I get? Well, I can just visually combine all of these into one array of 4 rows of 7, 5 plus 2. So we have 20 plus 8, which is 28. So because 4 divided 20 and 4 divided 8, then 4 is going to divide their sum, 20 plus 8, which is 28. Okay. We can take this a step further, and we can also look at products. So if a divides b, then a is going to divide any multiple of b. Okay. So, for example, 4 divides 8. 4 goes evenly into 8. And so 4 is also going to go evenly into 8 times 3, which is 24. So here we have 8 times 3 things, which is 24. And we've written this as 4 rows of 2 plus 2 plus 2, which is 6 boxes. Okay. And so let's combine the previous two pictures into the following. So if a divides m and a divides n, then a is going to divide any multiple of m plus or minus any multiple of n. Okay, so km, it just means multiple of m, and ln means any multiple of n. So I'll explain why the minus is there in a second, but let's just pretend that there's a plus for now. So 4 divides 20 and 4 divides 8, right? So the claim would be that 4 divides a multiple of 20 plus a multiple of 8. So here I have 2 groups of 20, and I have 3 groups of 8. So if I wanted to represent 2 groups of 20, that's represented visually by this, and 3 groups of 8 is visually represented by this. So here's my 40, here's my 24, and we can represent this entire number as just 4 rows of a bunch of boxes. How many boxes? Well, we had 5 boxes for the 20 at the start, and so now we have 10 boxes from that, and now we're going to have 3 times 2 boxes for coming from the number 8. Okay. And last thing, what's going on with the minus? So with the minus sign, I could have up here, let's just do it with this right here. So if a divides m and a divides n, then a is also going to divide m minus n. So let's just say m minus n up here. And so visually, I have, if I wanted to do 20 minus 8, instead of adding the 8 boxes, I could have taken away these 8 boxes. So take away these 8 boxes, and how many are we left with? We are left with still 4 rows of some number of boxes. So this is now going to be like 5 minus 2, which is 3. Okay. And so you could do the same sort of thing over here. You could do, if you wanted to do 2 times 20 minus 3 times 8, you could have just taken away the 3 times 8 boxes. So take away this many. Well, it's not overlapping nicely, but take away six of those columns, which would be this many. And then you're still going to be left with 4 rows of some number of boxes. Okay, so again, this is a very important and useful tool. You probably shouldn't understand why this is useful yet, but we will see in the next section why this one application of why this is so useful when we get to greatest common divisors and least common multiples and stuff like that. So more on that later.